So, good morning, everyone. So, basically, our project is based on the predicting hotel booking cancellation. So, we in group one have 6 members: Umang, Taiba, Vipin, Bhavya, Prakash, and myself, Nikunj. So, basically, our project is based on building a machine learning model which helps the hotel owners to better understand if the customer is going to honor the reservation or not. So, the main motivation behind our project is that the problems with cancellations, as we all know, that customers are easily accustomed to free cancellation policies that are provided by different websites, right? So based on this, and even they easily cancel the reservations based on the online reviews that they receive. So this, along with the fact that the hotel owners don't have any accurate method to forecast the customers that are going to show up. So all these things leads to non-optimized occupancy, over management, and revenue loss. So we found out a dataset from Kaggle. This dataset contains the variables like number of adults, number of children, number of weekend nights, number of weeknights, type of meal plan, required car parking space, room type reserved, lead time, which is the number of days between the date of booking and arrival date. Then we have arrival year, arrival month, arrival date, market segment type, which is again based on the market segmentation based on the booking done by customers. Then we have repeated guest, number of previous cancellations, number of previous bookings not cancelled, average price per room, number of special requests, and then we finally have our target variable booking status, which is a categorical one. So this is the basic data set that we have used. As you can see in this data set that we have lead time, this one, and average price per room. Both of these variables have a continuous variable and have a vast range of values in it. In addition to this, there is also arrival year, which has two values, 2017 and 2018. So this dataset was basically for the period of 2 years from 2017 to 2018. So this was the dataset that we used. Moving further, actually we had two data sets. First one was training data set and the other one was test data set. Both these data sets had approximately 18,000 instances and had 18 columns, out of which 17 were predictors and one was dependent variable. Now, this dependent variable was booking status, which has two values, one for cancelled booking and zero for honored booking. Out of the total data set, there was 67% of data set which reflected honored booking and 33% of data set reflected cancelled booking. So these percentages were derived from the Python programming as shown here. Moving further, we did some correlation analysis between the predictors and we found out that there was no significant correlation between any variables. Hence, we considered all variables for our further modeling purpose. Moving further, we did some exploratory data analysis where we found out that cancelled bookings have approximately higher average lead time. In addition to this, cancelled bookings even have higher average price per room. Moving further, we even found out that arrival year 2018 has higher bookings and higher cancellations too compared to 2017. Also, predictors, repeated guests, and number of special requests were negatively or inversely correlated with the target variable. So this was some information that we found out using exploratory data analysis. After that, we did some normalization and conversions of the required columns. As stated earlier, this average price per room as well as lead time both had vast range of values, right? So we did some normalization using these values and we derived these two columns, average price normalized and lead time normalized. We even converted this normalized lead time column into categorical lead time, as we know that some algorithms in machine learning requires categorical variables. That's why we converted this lead time normalized to lead time categorical just by uh, that normalizing this thing, right? So further, we even converted 2017 year to 0 and 2018 to 1. and this arrival date was converted using this logic. So this was some normalization and conversion we did to certain columns. Moving further, we also looked out for any missing data or null values in our data set, and we found out that there were no missing values. So we finally concluded that the data set we had was a clear data set, and we can further use it for machine learning. Over to you, Taiba.
Here, what we did is that to overcome the overfitting problem, we have divided our set into two parts, label and features, where we divided that label and feature into 4 data sets. Here, trained test splits model is used. In the tests, in this, the model, the same data set as we were trained will lead to an overfit and poor performance in a real life scenario. In order to avoid that, we split our data into 2 pieces, train sets and test set. Splitting the array and a matrix into random train and test subsets. So we divided our train sets into 4 parts: training data, test data, Y training data, and Y test data. Next slide, please. Where we use the engineering models, we use k-neighbor classification to find the accuracy. With a higher model with a higher accuracy, we will accept that model only for our cross validation or for prediction only. In the k-neighbor classification, we are getting 83% accuracy. Means the model predicted the class correctly for 83 of the samples in the test data. Next slide. Another, we use the logistic regression for the to find out our fit and our accuracy, how much accurate our model is for this test data. So we are getting 79% here. Then we have applied, next please. Here, we have applied XB classification. It is also a supervised machine learning method which provide accurate result and highly scalable method that avoid overfitting. So where we get 86% of accuracy. So we have choose this model for our cross validations over the test sets. So this is our snippet of our final output of XGP cross validation, where we got that booking status predictions as 001100 like this. For more verification and more clarification, we have used orange also for our data sets. Next slide. Here we use orange for we use random forest for our models to find out how much accurate our model is for this data, where we find that 89% are predictions is 89% is accurate for this model is 89% accurate. So for this also we did a cross validation and found out that, next slide, that we got the output as 00111100, means the previous predictions for XP classification and this random forest were almost same here. Hence, we proved that we were almost accurate with our prediction. Next slide. Thank you. We end with our ML model.
Okay,